Hello again. So today what we're going to do is we're going to talk about the Pythagorean Theorem, right? So now you got a lot of choices of videos. Thank you for choosing mine to watch about this. All right, so a lot of this we did during class, right? So if you don't have all of this filled in, it might be because you were absent, right? If you want to ask about it next time you see me, that's perfectly fine. I would recommend that. But just to kind of recap the Pythagorean Theorem itself, right? This is the big whole deal. A squared plus b squared equals c squared. Right, and the place that we get that, and let me just kind of actually just scooch this over so we can have it all on the screen at the same time, right? Oops, I guess we're scooching everything over, that's okay. If we have a squared plus b squared equals c squared, the a and the b are the legs of a right triangle, right? We can only use the Pythagorean theorem with right triangles, right? So if I take one leg plus another, square it, add on another leg squared, that will give me the hypotenuse squared. Right? If you're ever unsure about which one is the hypotenuse, for one, it's always the longest side of a right triangle. And two, you can always know that it's across from where the right angle is in your right triangle. Right? So if I just travel across from that right angle, I'm going to find that that's the hypotenuse side. Right? So again, this is only for right triangles. Right? It's named after Pythagoras, this guy that was around 2,500 years ago, which is kind of crazy. Like, you don't think about people 2,500 years ago as being, like, oh, the top minds of all time, right? But honestly, some of these Greek mathematicians, for sure, really found out some interesting stuff. So, like I was saying, the other day in class we did this proof of the Pythagorean theorem. This is the way the Pythagoras did it. We skipped over President James Garfield. Sorry, Jimmy. All right, what we're going to do today is we're going to talk about these like problems that involve the Pythagorean theorem, as well as these Pythagorean triples, which are real handy, right? So a Pythagorean triple is a set of three whole numbers that can be the sides of a right triangle, right? That just means that they work in the Pythagorean theorem. If you plug them in, they will actually work out well. When we're talking about whole numbers, right, think about, like 3.2 is not a whole number. 7 is a whole number, right? So it's just something that doesn't have a decimal. It's not a fraction. It's just a regular whole number, right? So if we wanted to find the missing side of this triangle using Pythagorean theorem, right, let's take a look. We already know the hypotenuse, right? So this is going to kind of be our c in the equation, right? The other two, right, the 12 and the x, that's going to be kind of like our a and our b, right? So we're not going to use a, b, and c, right? But just to kind of equate it to what we were talking about a little bit earlier, right? It's a squared plus b squared, and that's going to equal c squared, right? So one leg squared plus the other leg squared gives you the hypotenuse squared, right? All I'm going to do here is I'm going to plug in all those pieces that we know about, right? So c was that 13, so 13 with a little squared on it. A was 12, so 12 squared. And then as far as the b goes, we didn't know what that was, right? B was just x, so x squared, right? So this is all we're doing, right? We're setting it up using our Pythagorean theorem, and from here we can just solve this out, right? We can go ahead and say, all right, what's 12 squared? That's 144. All right, so 144 plus x squared is equal to 13 squared, right, which is 169. Okay. After that, what I need to do is I need to start getting that x all by itself, right? So I'm going to move that 144 over to the other side, away from where the x's are. Right, so now we have x squared equals 25. Right, and you might be thinking to yourself, like, oh yeah, all right, then I know exactly what it is. But what we want to do is sometimes the numbers aren't going to come out so nice, right? We want to know what is this next step, right? Like if it was this, if we're trying to say x squared equals 43, I need to know what I'm doing so I can use a calculator to help me find my final answer. So to undo this square, right, I have x squared. To undo that, I need to take the square root. And I need to do the same thing on the other side to keep everything nice and even. All right. If I take the square root of x squared, that's just going to give me x, right? Again, they undo each other. It's just like up here, right? We did 144 minus 144, right? That was because we had a positive. We needed to cancel out, so we did the opposite thing, right? We subtracted. This is the same deal, right? Down here, to undo this x squared, we had to take the square root of it. right? To take the square root of 25, right, you just think about what number times itself would give you 25, right? And you get 5, right? If you wanted to plug it into a calculator, that's also perfectly fine, right? On here, I'm going to hit the second button, and then I'm going to hit the x squared button. It's a little bit further down, right? You can see that it has a little teeny tiny yellow, like little check mark. That is your square root. You plug in, 25, and there you go. If you were using something like if you're using Google for a calculator, you could also type it in as squirt with some parentheses 25, and then hit enter, and it will give you 5 as well, right? But that's what we're looking for, right? Our answer is that this side length, this missing side length, was just 5. So not too bad, hopefully. All right, let's try another one out. All right, same kind of deal. We've got these 2 legs. We've got this hypotenuse. So I know that in this case, right, it's going to be 1 leg squared plus the other leg squared, right? So 9 squared plus x squared is going to give me the hypotenuse squared on the other side, right? So let's do this out, right? 9 squared is 81. 15 squared, I plugged it into a calculator a little bit earlier. It's 225. Right? After that, we're just solving it out, right? Subtract 81. Subtract 81 over there as well. We get that x squared is equal to 144. And then again, this is our new step, right? We're taking the square root of both sides, right, to undo that x squared part. So we're just going to be left with an x. And then square root of 144 is 12. All right, so that's that missing side on here. Right, so hopefully this doesn't seem so bad, right? I know we just kind of blazed right through that one, right? But that's really all it is, right? Set it up with the Pythagorean theorem, solve it out like an algebraic equation, right? Hopefully the only real new things are, the setting it up, right? Getting that first piece and doing this square root part on each one a little bit later on, right? So what we're going to do is we're going to take a look at a couple that don't come out quite as nicely, right? On these last two, we actually had Pythagorean triples, right? We had side lengths that were all just whole numbers. The first one was 5, 12, and 13. This one was 9, 12, and 15, right? So 3, 4, 5 is another Pythagorean triple you might run into now and then. But what we're going to do is we're going to take a look at some that don't come out as nice. Right? We need to find the missing side. So it's telling me that my legs are x and 9. My hypotenuse is 10. Right, so I'm just going to set up the same way. X squared plus 9 squared equals the hypotenuse squared. Right? Solving it out, it's going to look like this. We're going to get x squared plus 81, right? That's what 9 squared is, equals 100 on the other side. I need to move that 81 over, right? So because it was plus 81, I'm going to subtract 81. So x squared is going to equal 19. After that, we got to do the square root to figure out what that is. Right? I'm going to scooch mine over to the side because I kind of ran out of room. X is going to be equal to whatever the square root of 19 even is, right? So sometimes you might end up with answers where it doesn't come out real nicely, right? Like square root of 19. I'm just going to clean that up a little bit. So when it comes out as something that's not very nice, you could leave it as the square root of 19. But what I would really recommend is get in the habit of trying to figure out what that is as a decimal using a calculator, right? The reason why is because square root of 19 is really hard to think about. It's like, what even is that close to, right? Like, what kind of number is that? I can kind of guess that, like, maybe it's kind of close to 4 because, like, it's sort of like square root of 16, but a little more, right? But use a calculator, right? So I'm going to plug that in. I'm going to find the square root of 19. It's 4.3, and we'll round it to 6. All right, so let's call it 4.36. So when we're working on problems like this, right, it's perfectly fine to leave it as square root of 19. But again, it's a good habit to get into to try and get it to be 4.36. Because like 4 and a little bit more, right, it's like 4 1/3 is a much better number to be working with on a lot of cases than it is to work with, square root of 19. Oops. Seems like my pen might have bit the dust. That's kind of an issue. All right, so what we're going to have here is that we want to be saying that the square root of 19 is our exact answer, right? And 4.36 is our approximate answer, right? It's just like if I'm taking a look at, the calculator that I just had up a second ago, right? 4.358898944, right? That's not exactly what I wrote, but 4.36 is pretty close, right? We're going to have that as an estimate, right? Alrighty, sorry for the little blip there, right? My Apple Pencil disconnected. I think I've got it back working now, right? So what we were just finishing up talking about is the fact that the square root of 19 is our exact answer, right? Because it's exactly what it should be. And then 4.36 is our approximate answer, right? Nothing particularly right or wrong about either one of them. Square root of 19 is perfectly fine. But again, try and get in the habit of using 4.36 if you have a calculator handy, right? So what I want you to do is pause here, try out this next one for example 4, right? Let's see what it comes up as. All right, so if we gave that a shot, right, let's take a look. If I've got legs of x and 10, then I'm going to set that up as x squared plus 10 squared. The other side of this is going to be the hypotenuse squared, which was 20. Right? So if I zoom in on that, let's take a look. 10 squared is going to be 100 over there on the left side. 20 squared is 400 over on the right. To solve this out, I need to move that 100 away from my x's. So I'm going to subtract that from each side. X squared is going to be equal to 300 here. And then this is where I got to take my square root of both sides. We're just going to be left with an x over on the left, right? Because again, they just kind of undo each other. And then the square root of 300 is the square root of 300. Oh boy, who could have seen that coming? All right, but again, that's our exact answer. Figure out the square root of 300. Let's plug that on in. It's about 17.32. All right, let's round it off at that. All right, so again, either one's fine. 17.32 is probably like the more... It's going to sound a little weird, right? The approximate answer is the more correct one, right? That's the one that most people will probably want. But again, they mean the same thing. All right, so we got a couple of word problems here. What I'm going to do is we're going to talk through a couple of these together, and I'm going to leave the other ones as ones for you to try on your own and check on the notes that I'm going to upload a little bit later for these, just so I don't end up talking to you for 45 and a half minutes. So let's talk about this first one. The length of a soccer field must be between 100 and 130 yards. The width must be between 50 and 100 yards. I want to figure out what's the range for the lengths of that field's diagonal. All right, so we want to figure out a range of lengths. All right, so we need to look at the smallest possible case and the largest possible case. All right, so for the smallest one, the length would be 100 yards long. The width would be 50. For the biggest possible field, right, we'd be looking at 130 and 100 back up in the problem there. All right, so let's take a look at the small one first. Length of 100, width of 50. So we're going to draw ourselves out a rectangle, right? You might be thinking to yourself like, well, weren't we doing stuff with triangles? Yeah, you're right, but we're going to get there. Hold on. So we've got 50 as our width, 100 as the length, and we are specifically looking for the length of the diagonal of this field, right? So I'm looking to see, how far is it from one corner to the other, right? So what I'm going to do is I've got a couple other sides that I can label, right? This top side is also 100. This other side is also 50, right? And to figure out that missing piece, right, I don't know what it is yet, so I'm just going to call it X. Right? Always a safe bet. So what we're going to do here, to figure out what that X is, right? That's kind of like the hypotenuse of a right triangle, right? The soccer field, assuming it's, a normal, regular soccer field, 90 degrees at each corner, right? So what I'm going to do is I'm just going to highlight it for a second there, right? We're going to be taking a look at this right triangle right there. Right? So what we know is that we have side lengths, legs of 50 and 100. So I'm going to set those up in our Pythagorean theorem. 50 squared plus 100 squared is equal to that hypotenuse squared, right? That x that we're looking for. Right? After that, it's just a matter of solving it out like the last couple problems. 50 squared is 2,500. 100 squared is 10,000. that's equal to x squared. Right? If I smush those numbers together on the left-hand side, I'm going to get 12,500 equal to x squared. Right? After that, I still need to take the square root of both sides. And a doop. When I take the square root of x squared, it's just x. When I take the square root of 125 or 12,500, let's see what the heck that is. So square root 12,500. Whew, glad I plugged that in. It's 111.8, let's call it. Right? So what we're going to do here, right, is we're going to take a look back through the problem, see if, like, all right, does that make sense? 118.8 yards, right? If I'm running across a soccer field that's 100 yards long and 50 yards wide, that seems like it would make sense, right? If I ended up with something like 530, right, that might not seem as reasonable, right? So think about what your answer means in the context of the problem, right? That might help you check your work, right? See if you're right or wrong. Last thing I need to put on that 111.8 is yards, right? We're talking about a word problem. We should use our units, right? Everything else is talking about 50 and 100 yards. We're working in yards, right? The other half of this problem, right, is working on the largest possible field, right? So this one was 130 yards long and 100 yards wide, right? So maybe something like that. So 130 long, 100 wide. Right, and again, just like on the last one, what we're doing is we're looking for the length of that diagonal that runs straight across the field. Right? So same deal, right? The soccer field has still got a 90-degree angle in that corner over there. We're still looking for that missing middle piece, which we're going to call x. Right? So setting it up, I've got legs of 100 and 130. So I'm going to set those up with Pythagorean Theorem, same way we did on the last one. It's going to equal out to be x squared on the other side. If I simplify those, 100 squared was 10,000. 130 squared is 16,900 equals x squared. If I smush those numbers together, I'm going to get 26,900 equal to x squared. And oh, that's a heck of a number. I don't want to figure out what that is, right? We're going to take the square root of both sides. Oops. So the square root of 26,900, yuck, is 164.01, but we'll just call it 164. No, let's round it off. It's not exact. All right, so that is the x for this second half of the problem, right? And again, we're going to put yards on there. So we're talking about yards. So when I'm looking at my final answer for this problem, right, what is the range for the lengths of the field's diagonal? It can be anywhere from 111.8 to 164.01 yards, right? That's really what it's asking for at the end of the day. All right, so it's a lot of work, right? I'm not going to say like, oh, wow, that was really quick, right? But hopefully it doesn't seem all that bad. We're using the same Pythagorean theorem we were doing on the last couple. All right, so what I'm thinking is let's skip down to do number 7, right? I'm going to leave number 6 for you guys to do, right? Number 7, painters are working on the side of a building. They need to determine how tall of a ladder they need in order to safely place it so it won't tip over. The wall is 3 meters tall, and the painter places the base of the ladder 2 meters away from the base of the wall to be safe. How tall is the ladder? So let's take a second. Let's draw ourselves out a little diagram here. Right, this is the building. Right, wow, look at those doors. Look at those. Those are windows, Mr. Pog. Right, look at that building. Whew. Oops, let's not erase the building. Good enough. So we got this building. We've got the ground. And then we've got this ladder that's leaning up against the building. Right, so let's say something like that. Right. So I'm leaning that ladder up against the building. The wall that we're trying to get to, right, is 3 meters tall. Right, so in my diagram, I'm going to label that this piece right there is 3 meters. We're placing the base of the ladder 2 meters away from the edge of the wall. Right? We're trying to figure out what the heck, how tall is this ladder, right? And the reason that a diagram is helpful is because if you're thinking about how tall is the ladder, you might have been thinking about like, all right, what is the, actually, let's use different colors, it stands out a little better. You might have been thinking to yourself like, what the heck is that height if we're talking about how tall something is, right? But the ladder itself is what we're looking for, right? We don't know how tall it is. Remember, they base ladders on how tall they stand up and down. All right, so same deal. I got my Pythagorean theorem raring to go. I know that I've got legs of 2 squared and 3 squared. I'm going to set that up with that x squared on the other side. Right, again, same idea as what we were just doing for those other ones. If I simplify this down, 2 squared is 4, 3 squared is 9, 4 plus 9 is 13. Then again, our last little bit that we need to do to solve this out is use our Pythagorean theorem. All right, so the square root of 13 is, let's find out. Call it like 3.61. Right, so 3.61, and again, word problem, meters. Right, so hopefully this doesn't seem so bad, right? The word problems are very wordy as they come, right? But at the end of the day, we just drew ourselves a diagram, right? We have this diagram here. We've got this ladder facing up against this wall. We labeled the information they told us, and then it was Pythagorean theorem problem. Not too bad. Right, so again, I'm going to leave number 8 to you as well. 6 and 8 I'm going to do out before I upload these notes into our Google Classroom folder there. So if you would like to check your work on them, please be sure to check in there. You can also ask me and see if they're right? But I don't want to be talking at you for too long. So I'm going to wrap this one up, and I'll see you next time. Peace out.